Okay, when it comes to concentration, these are probably the most challenging scenarios for students to get used to. Not because the math is difficult, but because you have to really understand what volume, mass, and concentration represent. And you have to set it up consistently so that you know what things mean. You interpret the correct scale of what you're dealing with. So let's walk our way through this. Most of these can be set up with a simple proportion, a couple of fractions, you cross, multiply, and divide. The math is easy, but it requires long-term, consistent attention being paid to what do these numbers mean. You can't just throw numbers in and then expect to do some math and all of a sudden an answer appears. You'll get an answer, but you have to keep track of what these numbers represent. So let's jump in and take a look at this. We have a patient that's supposed to get 18 milligrams of a painkiller. So this is what they're prescribed. Okay, that's the dosage they're supposed to get, 18 milligrams. Trouble is, when you're going to administer this painkiller, it's already as a solution. Okay, it's a solution that would be administered through their IV tube. Okay, so it's not like you can just go to a scale and weigh out 18 milligrams. It's already dissolved in water. You need to know how much of it to give them. Okay, so you have a concentration to deal with. On the bottle you're using, it says it's 200 milligram percent. Okay, there's a meaning behind that. We need to know how many cc's we should put into a syringe and actually inject in there. So there's a lot of stuff being thrown at you here. All right, first thing I'm gonna bring up something we talked about a long time ago and we've dealt with occasionally since. cc's is the same as milliliters. Okay, a cubic centimeter, a cc, and a milliliter are identical. So from here on out, cc's might be the common phrasing, the common description that's being used, but I'm going to interpret it as milliliters. Okay. The other thing we're going to have to do is we're going to have to take a look at this over here. We've dealt with milligram percent. That's one way of saying it. We need to unwrap that and know what that means. So you have to know that 200 milligram percent really means 200 milligrams per deciliter. And I wrote it a little different than usual because I know where I'm headed with this. 200 milligrams per deciliter. You need to recognize that piece of the puzzle. This might be on the bottle. This is more useful to us when it comes to actually dealing with numbers and units and knowing what they mean. So 200 milligrams per deciliter. Now I want you to think about what that means. Per deciliter. That means per 1 deciliter. So there's actually a number down there. We don't write it all the time, but there is a 1 there. 200 milligrams in every 1 deciliter. I only want 18 milligrams, so I'm going to need a lot less than 1 deciliter. So think about this. This is a proportion. If there's 200 milligrams in every 1 deciliter, I'm just going to draw a little bit out to get my 18 milligrams that the patient needs. So I'm going to set this up. Milligrams on top, deciliters on the bottom. Milligrams on top, deciliters on the bottom. I want 18 milligrams. So here's the solution I have. Here's what I want to administer. I'm really going to be looking for this unknown down here. Now how do I solve for that? That part's pretty easy. That part's not so bad. We're just going to cross multiply. So we get 18 milligrams times 1 deciliter equals 200 milligrams times x. Okay. And I'm going to try to get x by itself. All right. This is pretty typical. And divide by 200 milligrams. Okay, divide 200 milligrams over here. Now take a look at our units. Milligrams is going to cancel with milligrams. I'm left with deciliters. It's really important that I recognize if this side is deciliters, my final answer here is going to be in deciliters, and that may not be what I really want. It might not be a realistic scale to put it on for this particular patient. Okay? So if I go through and I plug all that stuff in, 18 divided by 200, okay, you grab your calculator, 18 divided by 200 gives me 0.09. So I get x equals 0.09. Now 0.09 what? Well, that would have been deciliters. That isn't what I was looking for. I wanted to know how many cc's to give them, which translates to milliliters. Those are identical. So I don't really want it to stay like this. I would like this to turn into milliliters. So I'm going to move my decimal 2 spots because I can convert deciliters to milliliters. It's a factor of 100. 100 milliliters makes up 1 deciliter. 0.09 becomes 9 milliliters, which is the same as 9 cc's. And that's how much I would draw out to actually give this patient in one particular dosage.